Hello everyone, my name is Eric. Today I want to talk about the LeetCode challenge of the June 13th. And the problem is the largest divisible subset. Given a set of distinct positive integers, we want to find a largest subset that for each pair will satisfy this condition. Si modulo Sj is equal to 0, or Sj modulo Si is equal to 0. For example, if the input is 1, 2, 3, the answer will be 1, 2 or 1, 3, because 2 is a multiple of 1, 3 is a multiple of 1. And it cannot be 1, 2, 3, because 2 is not a multiple of 3, and 3 is also not a multiple of 2. And the first solution that can come to my mind is to enumerate all the results. However, it will take exponential time, and it is too slow for this problem. So we have to store some redundant computation and use a dynamic programming approach. But we have to think what is the redundant computation we can save. So we can look at the formula that will be a core concept of this problem. If x is a multiple of y is a multiple of g, then x is a multiple of g. And if we store the result of the dpy, which is the largest subset with the maximum value y, for each value for each y, if we store for each y smaller than x, then if we meet an x, if the x modulo y is equal to 0, we know that there will be a larger subset which is equal to dpy plus x. Why? Because for the element, y must be the multiples of all the elements in dpy. So if the element is g, this term must be satisfied. And x is also a multiple of y, and it means x is the multiple of all the elements in the dpy. So if we save this, it can save our time because we don't have to calculate the condition inside the dpy again. And let me use an example to explain this idea. Here I want to store dp0, which is equal to dp1. dp0 it means the dp1 means the first element. Well, I use the first element as a maximum value y. And dp0, dp2, and dp3. I want to store this. I want to store in this way because I want to use an array. I don't want to use a hash table because I don't want to spend the time to calculate the hash function, and it will be more efficient. And for the dp0, we know the largest subset will be 1 because there is no element smaller than 1. So this is the only answer. And for dp1, we know that we can it must be have 2 because 2 is the maximum value. And what we have to do is to check whether 2 modulo 1 is equal to 0, and it is true. So we have a larger subset, which is 1 and 2. And for dp2, we do the same thing. We check whether its modulo 1 is equal to 0, and it is true. So we have a larger subset, which is 1, 2, 4. 1, 4, sorry. And if 1, 4 modulo 2 is equal to 0, and it is true, then we have, because for dp1, we have 1, 2 here. So we can find the largest subset, which is 1, 2, 4. And for dp3, we do the same thing, which is equal to dp8. And if a modulo 1 is equal to 0, and it is true, so we have a larger subset, 1, 8. And a modulo 2 is also equal to 0, so we have a larger subset, 1, 2, and 8. And a modulo 4 is also equal to 0. So we have a even larger subset set that is 1, 2, 4, 8. So use this concept, we can design a dynamic programming approach which is much efficient. And we can analyze the complexity. For each key in the DP array, we have to spend at most big O n time, because uh, the key that spend the most of the time is the DP3, and it is at most the n elements. So the total time complexity will be n squared, because we have to store n element here, and for each element we have to spend big O n time. And then we have to find the largest subsets for each key in the DP array, and it will take big O n. So totally, it is still a big O n squared algorithm. And the implementation is comparable easy. First, I want to sort the array because I want to find the smaller DP y first. And then we will initialize the DP array, and we just follow what we have done here. And if we find a better solution, we will update it. And then we find the maxima, it will be the answer. And there is some boundary condition. If there is no elements in the input, we should return an empty array. And yes, and I think I have finished explaining the questions, and I hope you can understand. Thank you for listening my video.